A very good evening to all. How are you all? How is everyone? Very good evening, guys. Vinash, definitely it is possible. But since right now our focus is on the gate examination, since the gate examination is right at the doorsteps, so our focus currently for all the students is currently to prepare for the gate examination, to get a good rank in the gate examination. After the gate examination, we can definitely think of such a series in which we can discuss about the important software such as eTabs, StatPro, SAP, and various other safe. What are the uses of those softwares, how they are used and how they are useful in our structural designing. We can talk about that as well. Okay. Good evening, Rajesh. Good evening, Ashish, Pranjal. Good evening, everyone. Welcome, guys. Welcome. So in the today's session, we are going to talk about the introduction to the limit state method. We are going to discuss few numericals based upon the limit state method introduction. Now our focus in this session is, in this series that I have taken right now, my focus is that your revision should be there, that you shall be able to revise your subject through the numericals. So over here, the number of questions are not important, guys. Okay, try to understand over here. The number of questions are not important. The analysis of the question, the concepts, the background of the question is important, and on which I am going to give an emphasis on in each and every question. We are going to talk about the analytical things, and those analytical things are going to be very helpful for you guys, because gate examination is going to frame questions which are going to test your concepts very deeply, guys. Are you guys ready for the numericals? Shall we start with the session, everyone? I want full energy from each and every one of you. Tell me, everyone, shall we start with the session? Guys, are you ready to learn some very interesting concepts? Yes or no? Okay, let us start with the session, guys. Let us start with the session. So firstly, I will introduce myself, everyone. My name is Rohan Goyal. And I scored an All India rank of 96 in GATE 2020. And prior to that, I scored an All India rank of 366 in GATE 2016. I have a master's degree in structural engineering from IIC Bangalore, and these are the subjects that I teach at Gradeup. Starting with the first numerical, a very good numerical indeed. Okay, and you must understand the concepts also behind this numerical. The minimum strain at failure in tension steel having yield stress as 415 megapascal and Young's modulus of elasticity as 200 gigapascal as per limit state method of design is. So what is the minimum strain at failure? Tell me, everyone, what is the answer? Minimum strain at failure. What is the answer, guys? Calculate and tell me which of these is the right option. Minimum strain at failure in steel. Now, let us understand the question. So in limit state method, suppose this is the concrete block. This is a concrete cross section. So this is the width of the section, and this is the overall depth of the section. And suppose you are provided some area of steel as well. This is AST. This is AST. Now for this area of steel and for this section, this is the depth of this is your neutral axis. This is your neutral axis. This is your neutral axis. And IS code recommends that at failure, the maximum strain in concrete, at failure, IS code recommends that this is the now I am showing you the strain diagram. Strain diagram. IS code recommends that the maximum strain in concrete, this maximum strain in concrete is 0.0035 at failure. This is a strain diagram at failure, guys. At failure. And in the steel, and at the location of the steel, and the strain diagram is going to be linear. And at the location of the steel, this value shall not be less than, this value shall not be less than 0.87 Fy upon ES plus 0.002. So this is the minimum strain at failure in the tension steel. And this is the strain diagram. This is the strain diagram. So what is this value coming out to be equal to? So it shall not be less than 0.87. Fy is 415 upon 415 megapascal divided by 200 gigapascal. Gigapascal converted into megapascal, 10 to the power of 3 plus 0.002. So it shall not be less than what value, guys? It shall not be less than 3.8 or 0.0038. Shall not be less than 0.0038. So C is the right answer. Sorry, B is the right answer, everyone. B is the right answer. Clear? Now moving on to the next question. A very good question. Another a very analytical question. You must analyze such type of questions. Consider the following statements. The modulus of elasticity of concrete increases with the increase in the compressive strength of concrete. Next statement. Brittleness of the concrete increases with the decrease in the compressive strength of concrete. Next question. Shear strength of concrete increases with the increase in the compressive strength of concrete. And which of the following statements are correct? So let me see what do you think the answer is? So tell me what is the answer from your side, everyone? What is the answer from your side, everyone? In the next session, we are going to be discussing numericals on design of beam using limit state method. Okay. So I am thinking, because since my emphasis is that your revision shall be done, you shall revise all your concepts through one question itself. You must be able to revise all the concepts through one question itself. So what do you guys prefer? Do you want to do more number of questions, or do you want to do one question which covers all the concepts? What do you want to do? Tell me, everyone. I want to know from you guys, what type of question do you want? Do you want to do one question which is a very good question and covers all the concepts, or do you want to do number of questions having small different concepts? Tell me, what do you want? So we are going to go accordingly. One question, all the concepts. What about others? What about others? You're okay with any two? You're okay with any of the method? Okay. More number of questions you want, Jayash. So let me tell you the concept behind that. Why actually myself as a faculty, I prefer teaching one question which covers all the concepts, because in that one question you are going to have at least, in one question you will have at least 8 to 9 small questions. And if you do this one big question, you will be able to analyze the full big picture. You will be getting a big picture. Okay. If you do small questions, you won't be able to have a good big picture. Okay. So if you want to have a big picture of the subject, then you must have to do a big question. So that is why I prefer to do a one good question, one big question, and by that your analytical skill will increase so good that you will be able to solve all the questions. Clear? It won't be a problem at all. Okay. Now let us proceed. Now what are the following statements are correct? Now the first statement says that the modulus of elasticity of concrete increases with the increase in the compressive strength of concrete, which is true, because modulus of elasticity of concrete is equal to 5000 under root FCK. 5000 under root FCK. Okay. So it is directly, your modulus of elasticity of concrete is directly proportional to the under root of strength of concrete. That means as the strength of the concrete increases, your modulus of elasticity of concrete will also increase. Okay, so first option is right. Second, brittleness of the concrete increases with the decrease in the compressive strength of concrete. Let us understand this through a diagram. Okay, let us understand this through a graph. So let us draw the stress strain graph curve of a concrete. So let us say this is the stress strain curve for M15 grade concrete. Let us say this is the stress strain curve of M15 grade concrete, and this will be the modulus of elasticity for M15. Now as the grade of the concrete is going to increase, your modulus of elasticity is also going to increase. So as for M20, you will get this M20, and the failure strain will reduce. It is seen that the failure strain will reduce as the strength of concrete is increasing. This is epsilon F1 and this is epsilon F2. So epsilon F1 is greater than epsilon F2, which means M15 is, or which means this is for M15, MF1 is for M15 and MF2 is for M20. That means M20 concrete is failing at a lesser strain. M20 concrete is failing at a lesser strain. Now further, if I increase the grade, it will further go on reducing. M25. Further I increase the grade, further it will reduce M30 like this. So the failure strain will keep on reducing. That means your concrete is becoming more and more brittle. It is becoming more and more brittle. That means M20 is more brittle as compared to M15. So it is saying that the brittleness of the concrete increases with the decrease in the compressive strength of concrete, which is wrong. It increases actually. It is wrong. The second statement is wrong. And if the second statement is wrong, your A option is not possible, your B option is not possible, and your D option is not possible. And your answer is C itself. You need not check the third statement. You need not check the third statement at all. But let us check, since we are here to analyze. Next is your shear strength of concrete, that is your tau C or tau C max. Tau C is including the strength of main reinforcement also. And tau C max is only due to the concrete. Okay? Tau C is the failure due to the diagonal tension and tau C max is the failure due to the diagonal compression, which we are going to see in the when we are going to do the shear design. Over there we will see this thing also. So shear strength of the concrete increases with increase in the compressive strength of concrete, which is also true, which we can see in the tables also. In the table which we have for tau C and tau C max, it increases, both the values increases, the permissible stresses in concrete increases as the grade of the concrete increases, as the grade of concrete increases, as FCK increases. Clear? So that is also true. So C option is the right answer, everyone. Is it clear to all? Yes or no? Let us move on to the next question. This question I guess we have done in the previous class also. So no need to let us skip this question. We have done this question in the previous class also. You can check it. Okay. Now this question. I will come back to this fourth question. But first of all, we are going to do this fifth question. Fifth question. The reinforced concrete section, the shape of nominal shear stress diagram. The shape of nominal shear stress diagram is parabolic over the full depth, is parabolic above the neutral axis and rectangular below the neutral axis, is rectangular over the full depth, and D option is rectangular above the neutral axis and parabolic below the neutral axis. Which of the following options are correct, everyone? Tell me. Which of the following options are correct? Tell me, guys. Which of the following options are correct? A very good question, guys. Answer carefully. It is asked nominal shear stress diagram. Nominal shear stress diagram. The question, it is asked to find out the nominal shear stress diagram, the diagram distribution of nominal shear stress diagram. So guys, the answer to this question is C. The answer to this question is C. Rectangular over the full depth. Now you will think, sir, how is it possible? How is it possible? It is not possible. It is B. We have studied B as a. No guys, you have studied C as. C is the right answer. You have studied it. You have studied C is the right answer. You will ask me, sir, how is it? We have studied B. We have studied it is parabolic above the neutral axis and rectangular below the neutral axis. We have studied it like this. So the shear stress diagram that you are referring to is the actual shear stress diagram. It is the actual shear stress diagram, guys. It is not the nominal shear stress diagram. Nominal shear stress diagram, the nominal shear stress is equal to V upon BD throughout the depth of the neutral axis. Throughout the depth of the section. It is throughout the depth of neutral axis. Throughout the depth of the section. So your actual stress diagram is like this. Actual shear stress diagram. It is like this, guys. Firstly, it is parabolic. up to the neutral axis point, and this value is V upon 2I equivalent. It is not, there is no need to remember this value, x square minus y square, and then it is linear up to the reinforcement level like this. And the value which is assumed for designing purpose is referred as nominal shear stress, which is a linear diagram like this, guys. It is a linear diagram like this. It is an approximated value like this. It is an approximated value, and this is your tau v, which is equal to V upon BD. Clear to all? So it is a rectangular throughout. It is throughout rectangular. Clear to all? So C is the right answer, guys. Okay, moving on to the next question. This is easy one. An RCC section under flexure, the assumption of plane section before bending remains plane after bending leads to which of the following assumptions? Strain diagram being linear across the depth, stress diagram being linear across the depth, both stress and strain diagram being linear across the depth, and shear stress diagram being linear uniform across the depth. Which of the four options is correct? Tell me. Which of the four options is correct? Tell me, guys. Which of the four options are correct? Tell me, everyone. Okay, so you think A is the right option. Strain diagram is linear. Yes, very good. Very good. Strain diagram is linear. That is right. Stress diagram will not be linear because it depends. If it is working stress method, in that we work only in the linear range. That is why we get a linear stress diagram in the working stress method. Whereas in the limit state method, we also work in the non-plastic range also, or non-elastic range also. We also work in the we have a parabolic region also, that is why. Okay, so stress diagram is not linear. So A is the right option. Okay, this one, read the question and tell me the answer. Another easy one. The design of limit state of collapse in flexure is based upon the which of the following? Plane section normal to the axis remains plane after bending. Maximum strain in concrete at the outermost tension fiber is 0.0035, and the relationship between the compressive stress distribution in concrete and the strain in concrete are assumed to be rectangular, trapezoidal, parabolic, or any other shape, which results in a prediction of the strength in a substantial agreement with the results of the test. So which of the following statements are correct? Tell me, everyone. Which of the following statements are correct? So I will quickly give you the answer to this one because it is easy. This one is right. This maximum strain in concrete at the outermost tension fiber is 0.0035, which is incorrect because it is outermost compression fiber. And the relationship between this is also correct. This is a direct statement from the IS code also itself. So A is the right option. Now this is a good question. Read this question and tell me which is the right answer. Combination of the partial factor of safety for load under the limit state of collapse and limit state of serviceability will be. Tell me which is the right option. See the options carefully and tell me which is the right answer. The partial factor of safety for loads under limit state of collapse and limit state of serviceability, everyone. Tell me. Tell me, guys. What is the right answer, everyone? Tell me, guys. What is the right answer, everyone? Tell me, everyone. Quick. Quick, guys, quick. What about others? What about others, guys? What happened? So let us understand. Let us see. So the load combinations which are given as first is 1.5. Let us first of all understand what are the load combinations. So limit state of, so let me give you the answers. Okay, let us first of all write all the load combinations, right? Let us first of all write all the, since the revision is our main target, I'm going to give you all the load combinations. Okay. For limit state of collapse, limit state of serviceability, right? We have three load combinations. That is dead load plus live load. Second is dead load plus live load, lead load plus wind load or earthquake load. And third is your dead load plus live load plus wind load or earthquake load. These are the three cases, three load combinations that we have. These are the three load combinations that we have. Okay. These are the three load combinations that we have. Over here, I am going to write the partial factor of safety for dead load, then live load, then wind load or earthquake load. Similarly, dead load, live load, and wind load or earthquake loads. Okay. Clear? So let us start writing. So for dead load plus live load combination. So for limit state of collapse, it is 1.5, 1.5 and nothing. And for limit state of serviceability is 1.0, 1.0 and nothing. For dead load plus wind load combination, it is 1.5, nothing and 1.5. It is 1.0, nothing and 1.0. And in special cases, when the Stability of the structure is to be measured again overturning. We also take 0.9 value. We also take 0.9 value when overturning is considered. So you can write over here, you can write over here overturning, for overturning. Stability due to overturning is considered. Then for dead load plus live load plus wind load combination, it is 1.2 into 1.2 into 1.2. And for serviceability, dead load is taken as full and live load and earthquake load is taken as 0.8 and 0.8. Clear? So these are all the load combinations. These are all the load combinations. Okay. These are all the load combinations. Now over here, which of the options give you all the load combinations? The first option 1.5 dead load plus live load, 1.5 dead load plus wind load, 1.2 dead load plus wind load, live load plus wind load, which is complete one for limit state of collapse. And dead load plus 0.8, live load plus wind load, and two more combinations are not there. See, overturning से decrease इसलिए हो रहा है अविनाश. Suppose this is your structure like this. This is your structure. Now the weight of the building is itself overturning the structure. It is contributing to the instability. When the overturning is concerned, suppose your building is on a hilly terrain, like this. Your building is on a hilly terrain. So in this case, your weight of the structure is further going to overturn the structure. That is why we take 0.9 factor in case of overturning. B option 1.5 plus dead load and wind load and dead load plus 0. Live load plus wind load, still incomplete. Third place 1.5 dead load plus live load, 1.5 dead load plus wind load, 1.2 dead load plus live load plus wind load, complete. And 1 dead load plus live load, 1 dead load plus wind load, and dead load plus 0.8 live load plus wind load, which is also complete. So C is the right option. And in the D option, in limit state of collapse, we are having only 1, so incomplete. So C is the right answer, everyone. Clear? Is it clear to all? Okay. Now moving to the previous question. This one. Coming back to the previous question, a very good question, guys. An unfactored maximum bending moment at a section of a reinforced concrete beam resulting from a frame analysis are 50, 80 and 120 and 180 kN under dead, live, wind and earthquake loads respectively, and design the movement, the design bending moment, in kN as per Indian standard IS 456 for limit state of collapse is. So what is the design bending moment? If you are given unfactored movements are given to you. Unfactored movements are given to you. For dead load is given as 50 kN. For live load it is given to you as 80 kN. Wind load is given to you as 120 kN. And earthquake load is given to you as 180 kN. And you have to find out what is the design load for limit state of collapse. WD or MD, sorry. Design moment as per limit state of collapse. So calculate, everyone. I will give you 2 to 3 minutes so you know all the load combinations. So these are all the load combinations. For limit state of collapse, you know all the load combinations. Okay. You know all the load combinations for limit state of collapse. Now see what shall be the design moment for all these load combinations. Calculate and tell me, everyone. Calculate it. Start doing the calculation. Get back to the calculations, guys. Start your calculations, everyone. Come on, do it and tell me. Now you know all the load combinations. Now you are a designer over here and you have to design this building. and you are given all the bending moment to the different conditions. And I am asking you, for which bending moment are you going to design this section? Tell me, everyone. Now, as a designer, which of the options are you going to select? Start your calculation, everyone. You are having three load combinations. First is your dead load plus live load. Second is your dead load plus wind load or earthquake load. Third is your dead load plus live load plus wind load or earthquake load. And you know the partial factor of safety for all the three load combinations. Apply the partial factor of safety and see which of the partial factor of safety gives you the minimum value. Simple as that. Which of the following will give you the maximum value? Simple as that. You have to find out the maximum value. Are you sure? Are you sure C is the right answer? Let me check. No. C is not the right answer. Yes, Abhinash, very good. D is the right answer. D is the right answer. Okay, let us see. Let us check. And from the tomorrow session, I want you, each and every one of you, to be on time. We are going to start the session at 7 p.m. itself. So if you are late, then you are not going to follow the question, because we are going to discuss only one question, right? So if you are on time, you will be able to follow the whole question. You will be able to follow the whole question. Okay. Now first load combination is for 1.5 dead load plus live load, which is equal to 1.4 movement due to the dead load is 50 plus 80, which is equal to 195. चैट्स बंद कर दीजिए अभी आप लोग, मैं समझा रहा हूं, यहां पे आप कॉन्सेंट्रेट कर कीजिए जरा, ठीक है. सेकेंड लोड कॉम्बिनेशन इज 1.5 डेड लोड प्लस विंड लोड और 1.5 dead load plus earthquake load, whichever is maximum, which will be equal to 1.5 50 plus 120 or is equal to 1.5 50 plus 180, which will be equal to 255 kilonewton meter, which is equal to 345 kilonewton meter. The answer which you are getting, Zela, third load combination 1.2 into dead load plus live load plus wind load or 1.2 dead load plus live load plus earthquake load, which is equal to 1.2 50 plus 80 plus 120 or is equal to 1.2 into 50 plus 80 plus 180, which will be equal to how much? 375. and it is going to be equal to no, actually it is, sorry, it is not 370, this is 372 kilonewton meter. This is 300, and this is 372. And which is maximum of all these values? So what is the maximum of all these values? We are going to design for that movement, right? Whichever is going to be maximum over here is you are going to design for that value. So 372 is maximum, so you are going to design for 372, not for, neither you are going to design for 195, neither for 250, neither for 245, you are going to design for the maximum, that is 372. Clear? Is it clear to all? Okay. So remaining questions are easy itself. So that's all for the today's session, guys. For any doubts, you can ask me. Okay. Meanwhile, I will introduce you all to the courses which are offered at Gradeup. We have Gear Up 2021 for Gate 2021. It is a basic concept building course. If you want to revise your entire Gate syllabus, you can subscribe to this course. Next is your Rank Up course, which is basically a score improvement course. Okay? And if you want to improve your Gate rank, you can subscribe to this course. And if you are aiming for Gate and ESC 2022, you shall subscribe to the Vision 2022 course. And if you subscribe to Gradeup Super, by Gradeup Super, you get subscription to all the courses which are offered at Gradeup, guys. You get subscription to all the courses, each and every one course which is offered at Gradeup. Okay. And these are the star faculties who are going to be guiding you through the journey. Okay. And these are our past achievers. We have 60 plus students in top 100 in Gradeup. And these are the subscriptions. We have 6 month, 12 month, and 24 month subscriptions in Gradeup Super. And for any doubts regarding the membership, you can contact on this given contact number, or you can also email on this given email address. And with Gradeup Super, you get unlimited access to all the structured live courses and mock tests. Now coming back to the doubts. What direction, Abhinash? Do you want me to repeat this question? What do you didn't understand in this question? Tell me, everyone. So in this question, what do you want me to repeat? Tell me your doubt more clearly and more. Express your doubt clearly, guys. In this, you want me to repeat the whole question. In this, these are the load combinations that you have just studied, right? Earthquake and wind load. See, guys, now the concept over here is we take into consideration only earthquake, either earthquake load or wind load. We take into consideration either earthquake load or wind load. We never take into consideration both the loads together. We never take into consideration both wind load and earthquake load together, because it is very less probable that on a structure the wind pressure is also very high and simultaneously earthquake is also coming. That is very less probable. Okay, further, earthquake is also dependent upon the direction of the earthquake, and wind is also dependent upon the direction of the wind. So for taking both the conditions together, that means we are assuming that wind is also acting in the same direction and earthquake is also taking place in the same direction, which is also very less probable, even further less probable. So it is extremely rare that wind load and earthquake load are going to take place simultaneously. So that is why in the load combination, either we considered wind load or we considered earthquake load, and whichever is going to give us the maximum value, we are going to take that value into consideration for the designing, guys. Clear? Plus minus sign? No. No plus minus sign is given in the load combination. It is always plus. Okay. So that's all for the today's session, guys. Thank you. Goodbye, guys. See you in the next session, guys. Yes, we are having free sessions in the app also. I'm taking free sessions in the app also. You can attend the free sessions in the app as well. Okay. Currently, my another series is going on in app also. Free series is being going on in app also. You can follow me on the Gradeup app. You will get to know all the series that I'm coming up with, all the sessions which I'm coming up with. Okay. So that's all for the today's session, guys. Thank you. Goodbye. See you in the next session, guys. Bye, guys.